Let us find out if there is any relation between their coefficients and the geometrical or algebraic interpretations. To do so, we start by finding the ratio of their coefficients. Let us write down the value of a1 by a2, b1 by b2 and c1 by c2 in the table below by comparing the pair of linear equations to their standard form, which is: what relation do you observe between the ratio of their coefficients and the graphical representation? Here, we observe that when a1 by a2 is not equal to b1 by b2, that is, the pair of equations has a unique solution or is a consistent pair of equations. Take the second set of linear equations in two variables. We observe that a1 by a2 is equal to b1 by b2, that is equal to c1 by c2, in the case of a pair of linear equations which has infinitely many solutions or is a dependent, consistent pair of equations. In the third set of a pair of linear equations which has no solution or is an inconsistent pair of equation, we observe that a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2. Let us summarize the ratio of comparing the coefficients, its graphical representation, and its algebraic interpretation for the different pairs of linear equations. So, given a pair of linear equations in two variables, we can find out the type of solution the equations will have by just comparing the coefficients of the two equations without any calculations or plotting on the graph. A pair of linear equations in two variables with the standard form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Intersect if a1 by a2 is not equal to b1 by b2. Coincide if a1 by a2 is equal to b1 by b2, that is equal to c1 by c2. Parallel if a1 by a2 is equal to b1 by b2, which is not equal to c1 by c2.